the red part is the x-axis, because every complex number can be plotted on the x-axis, just as you plot your physics graph. Yes. Every complex number can be plotted on what is called Argand diagram. Argand diagram. Yes, Argand. From argument means Argand. So every complex number can be plotted as a graph to the complex number. I can plot every complex number in diagram. Should I show you an example? Okay, let's say for instance, you are given a complex number C, which is equal to 3 plus 2i, for instance. Okay, do you know that before, every complex number can be written as z equals x plus iy? Are you aware? Yes. Okay, then if you compare these two complex numbers, can you see that the x will correspond to the real part of it? Yes. So the real part x is equal to 3. Imaginary part is the number with I, have it? Yes. Which means y is the imaginary here, but corresponding to imaginary here is a okay. So in your normal plotting, you normally have x, y as a coordinate. Yes. So if I do it the same way, it should be 3, so if I'm plotting, anytime you are given a complex number, the real part of the complex number is like this. This is y-axis, this is x-axis. Real parts are located on the x-axis, right? Why imaginary parts are located on the y-axis? That's why I call it imaginary axis. Y-axis is where you place the I people. X-axis is where you place the real people. So if I want to plot this guy as a graph, it means as you go to the x-axis and plot real, which is 3. Okay, let's assume 3 is here. You know what I'll do is I will now track it up. And so okay, plot the y person. Who is the y person? 2. So let's assume 2 is here. I'll plot 2. I will join them. Plot it. Then this is what we call the position vector. I will draw it from origin and join. This is the complex number in question. This is the position of your root. So this corresponds to z equals 3 plus 2i. You see? I am trying to tell you that every complex number can be plotted. Once I'm giving a complex number, I can represent it on the x and y axis, which is Cartesian axis. The Argand. Look at the spelling. Argand. The diagram I just drew like this is Argand diagram. If I plot a complex number on a graph, it means I do Argand diagram. Argand. So representing a complex number with diagrams or graph. So what I want to preach to you here is this. This is your complex number. There is an angle that this complex number has created. This is angle T. It created an angle because I plotted it. This space is an angle. The angle made with the complex number and the x-axis. This is that angle I'm referring to. So this will now be what we call the argument of the complex number, the corresponding angle. So plotting this complex number is as important as finding the argument. Okay, let's say for instance, don't worry. No problem. Okay, before I go further with this argument, I want to tell you that this Cartesian coordinate system, this x and y axis, which we can call 4 cardinal points. These are the 4 cardinal points in mathematics. Okay, then if you come to the Cartesian coordinate system, there are 4 departments, there are 4 chambers that I want you to know. This is the x and y axis. This is portion 1, portion 2, portion 3, portion 4, which is referred to, this place is called first quadrant. First quadrant. It's important to know the coordinate system. Anytime you draw y-axis and draw x-axis, you have created 4 chambers. This first place is where you call the first quadrant. This place is the place you call the second quadrant. Then this is the third quadrant. This place becomes the 4th quadrant. The 4th quadrant. So this thing is in reality. Now, from what we did before, this complex number I talked about before, where did it fall? It's well in the first quadrant. It's very important to know it's about complex number, especially when they say arguments. if they say you should find argument, the first thing you should do is where is this complex number set? Where is it from? Is it from first, second, third, or fourth? Okay, just like this. If I give you this complex number now and ask you where is it? Quadrant. This place is third quadrant. Okay, you are giving z to be equal to minus 3 plus 2i. Please, somebody should tell me the quadrant that the complex number will lie. How do I know? Let me tell you. If you want to know, don't be high. If you want to know it, don't be high. They use one. If you want to know it, plot it. If I want to know where it lies, I must plot it. Okay, let's say the x person in the ray pattern, minus 3 should be located on the x-axis. Which you know it is minus, which means left. Okay, I will now assume, okay, if minus 3 should be here, then I'll go to the y person. Y person is positive 2, huh? Since it is positive, it should lie up, which is going to be there. If I connect these two people, connect them. Where is this place? It's a second quadrant complex number. It is very important to locate. This is the address. If you don't know the address of a complex number, you cannot know is what, whereabouts. So any question they ask you about that person, you can't find. So if they give you another guy, z is equal to 3 minus 2i, where do you think it will lie? Ask this guy for me. First quadrant, well, let's just check. Okay, what this means is that I'm having the ray person as 3, which is not located on the x-axis. Since it is positive, it should be on the right. So let's assume 3 here. Then going to the y person, it is minus 2. Which means it should be down. Okay, if minus 2 can be here, then if I connect them, this lies in the fourth quadrant. Then, what if I change the complex number to this and say complex number you are giving is a negative 2i? You are giving z to be negative 2i alone. The ray parts vanish. Can you see it only has y person? So you only have the right to be on the y-axis. And if it wants to be on y-axis, it's only down because it's minus. And if it is plus, it can only be on the x-axis. So if I want to locate it, where I'll locate it is any place along x-axis, any place along, which is here. So if I connect it, this is the complex number here. It is lying on the axis. This is the type of complex number I call quadrantals. It's a quadrantal complex number. It is lying on the line. It's a quadrantal complex number. No, it doesn't have, it's lying on the border. It doesn't want to take away. It is just lying across the border. The name is quadrantal. Yes? Okay, important here now is that thing here is that you have know how to locate where a complex number is. Quadrantal. So you have now known where a complex number lies. It is important if you want to find the principal argument of a complex number. Okay, now I want to tell you how you can get it. If you come to the principal arguments of a complex number, there is what we call precursor. If you want to get the ray argument, there is somebody that will clear the time for you. They get. If you want to get the principal argument of a complex number, you need to go and get the key. The key is what we call reference angle. You have to get what is called reference angle. It is that reference angle that will open the door. You will now see the main angle. They get. So anytime they say find the principal argument of the person, you can get the key. The key is the what do you call it? The reference angle. Look at how we are going to do it. Okay, before then, I want you to copy this diagram again. Copy this diagram. In the first quadrant, this is first. Theta is equal to 1/8. Sorry, theta is equal to this. Write the diagram. Then in the second quadrant, theta is equal to 180 minus this. This theta is just arguments, the principal arguments. Then in this place, theta is equal to negative bracket 180 negative 5. It's very simple. Then here, theta is equal to negative 5. Then here, this is 90 degrees. This place is negative 90. Then this place is 0. This place is 180. What the diagram take it. I'll explain how you can memorize it. It's very simple. But once you have this diagram, it will be very easy for you to find principal arguments. Because principal argument is not always very direct. Theta is the principal argument itself, the main person you are looking for. This person I am writing like this, I look like what do you call it? Theta. This is phi, I mean. Okay, this one is the one I was telling you that it is the reference angle. It is the key. Once you can get this guy, it will help you get the main guy. The main guy is theta. Phi. No, phi. Forget about the name. Okay, I will tell you how to apply this diagram. We take a question. Okay, the question is find the principal arguments. The principal arguments of Z equals 1 minus, let's start with 1 first. 1 plus I. Find the principal arguments of 1 plus I. The principal arguments of 1 plus I. Okay, anytime you are looking for principal arguments, you look for the key, which is a reference. Don't just go straight and find your principal argument so that you don't fall into temptation. The first thing you are going to do is first, I will say find the value of I. Find this before finding this. This is the main guy, theta. The main person is theta. That is the principal argument himself. They lie. Did I now disappear? The principal argument is theta. But this theta cannot be gotten directly. Don't go and get it directly so that you don't fail it. Get this guy first, which is the precursor. So if I get this person will now direct me to the main person. So if I want to get this person has a formula. Look at the formula for getting the key. If you want to get the key, it is tan inverse. Tan inverse of y over x modulus. Yes, tan one. Wow. The formula. When I plotted for you, remember when I plotted a complex number for you? This is the complex number. This is theta. This is the value of y. I plotted y value is here. X value is here. This is a triangle now. A right angle triangle. Can you see? In this right angle triangle, there is y, here is x. And theta will now become y over. So theta will be tan inverse. That is how it came. But don't go that far. Just know that the rough angle is tan inverse of modulus. It's very important to know that there is modulus there. What is the meaning of this modulus in this aspect? What modulus means is if there is negative, throw it away. The modulus you are seeing here is not to go and be squaring anybody. What this thing means is if you are solving it, if there is negative in either y or x, throw them away. Because the work of modulus is to extract minus. Okay, so well, let's solve. Okay, I will now say therefore the value of my rough angle is tan inverse of modulus of who is y please in your complex number? 1. It's not I now 1. 1 over who is x please? 1. Okay, all is equal to tan inverse. Is there any minus there? No. Since there is no minus, the modulus has no work to do. Okay, get. Okay. There is no negative, so modulus doesn't have work. We remove it. the essence of this modulus is to remove any negative that is there. Modulus tells you that if there is negative in any of them, throw the negative away. They get. It is different from when you are looking for modulus of a complex number. That one, you square a part, imaginary part, right? And take square it. But this one is modulus of ordinary numbers. It's not complex number. She gets. So this is tan inverse of who? Okay, well, can you tell me the value of tan inverse of 1? 45 degrees. We are going to tell you in trigonometry. Or just know it. You know the value of sine inverse of half? What is sine inverse of half? That is the number whose sine is half. Okay. I want you to also know that tan inverse of 45 is also 1. There are some ones you should know. Then other ones, I will give you the way to generate them. But as time goes on, let this thing be something you have known now. Tan 45 is 1, have you? Okay, sine who is 1? Okay, cos who is 1? Cos 0 is 1. So if tomorrow now somebody asks you sine inverse of 1, you do price calculator. You should already know that the value that will give you 1 for sine is 90. So the answer is 90. If somebody says cos inverse of 1, you already know that for cos, the angle that will generate 0 is 1 is 0. The same way, if they say tan inverse of 1, you know that for tan, the person that will generate 1 is 45. So I will now say that this is 45. So this is the value of the rough angle or the precursor angle. This particular angle now we now generally carry go the main person. If you take us to the main person, which is the principal argument. Now, look at the address. I gave you the map. Look at this. This is the principal argument map I gave you. So the map will help you to know where the value will be. For example, I told you that if a complex number lies here, the answer is going to be the upper angle. If a complex number happens to be in second quadrant, it is 180 minus. Then if it is here, the angle is minus bracket 180 minus rough. Then if the complex number is here, the principal argument is negative of the rough. Can you see the mutual mirror image? Okay, now it is now up to you to tell me where your complex number is. Where does your complex number lie? Is everybody aware? Yes. Okay. First of all, I told you get the reference angle. The next thing we now do is where is the quadrant? Next thing, find the quadrant. Find the quadrant. Remember, our z was 1 plus I. Who can tell me the quadrant of z? You know, to know the quadrant of z, you plot it now. The x person is on the horizontal. Where will it lie? Here or here? Okay, if 1 is here, track it. Then the y person is also 1. Where will it be? Here or here? Then when you join it, where is this place? That is the meaning, the reason why we say it is first. I hope everybody now knows why. So our complex number lies in first quadrant. First quadrant. Okay, who can tell me the value of the principal argument in first quadrant? Okay, it's the same thing as the rough. Once you are in first quadrant, that person you are looking for is that key you are looking for. They get. That's the raw in first quadrant. So this is what we call principal argument map. So then what I will now say is, I'll say therefore